Today, we're going to talk about a silent killer in production systems, unbounded concurrency. Yeah, it's a problem that often hides in plain sight, and it can turn what looks like perfectly efficient code into a complete system-wide disaster. You know the story. It's almost a cliche if you've ever been on call. A service is just humming along, handling traffic, no problems. And then, bam, it's not. Alarms are blaring, latency is just through the roof, and servers are crashing left and right. And the worst part? There's no obvious bug anywhere. And it always begins with something that seems completely innocent. Your service just needs to process a list of items. Maybe a few thousand users or orders or files. And for each one, you gotta perform some async operation, like a database lookup or an API call. Simple enough, right?
So naturally, you reach for a really powerful tool in your toolbox, Promise.all. I mean, it seems perfect for the job. You just map your list of items to a list of promises, wrap it all up, and you're done. And in your staging environment, it's lightning fast. All the tests pass with flying colors. So the code gets shipped. But then in production, under real load, the whole system just collapses. Memory usage spikes, the database CPU is totally maxed out, other services start failing, pods are getting OM killed, that's out of memory, and even as new ones spin up, they just make the problem worse. They're just adding fuel to the fire.
So, why? Why did this happen? Nothing was blocking. Everything was asynchronous, which is supposed to be the right way to do things in node.js, isn't it? Why did our super fast, efficient-looking code bring the entire system to its knees? Well, that's the mystery we're gonna solve.
You see, the root of the problem is this fundamental misunderstanding. It's kind of an illusion about how asynchronous code actually works. We've been taught to think that non-blocking means safe, but that is definitely not the whole story. This right here, this is the dangerous idea. A lot of us have this baked into our thinking. We've been told for years that async is the key to performance in Node.js, so we just assume that as long as we aren't blocking the event loop, hey, we're in the clear. But this belief is exactly what leads to these huge, catastrophic failures. Look, asynchronous does not mean bounded or controlled. All it means is that the JavaScript engine can work on other things while it's waiting for an operation to complete. It puts absolutely no limits on how many of those operations you can kick off at the same time.
And that brings us to the real culprit, unbounded concurrency. This is what happens when you use something like Promise.all on a big, uncontrolled list. You're basically telling the system to schedule every single one of those operations immediately, all at once with no safety valve, no way to slow things down if your downstream systems just can't keep up. Let's just put a number on it to make it real. If you pass an array with 10,000 items into a Promise.all, you are not creating some nice orderly queue. No, you are instantly dispatching 10,000 concurrent operations. Think about that. 10,000 things all trying to happen at the exact same moment. And what this does is it creates a flood. Suddenly, your database gets hit with 10,000 simultaneous queries, and it just exhausts its connection pool. Your upstream APIs get bombarded with requests, which triggers their rate limits, and all the while, your Node.js service is trying to hold 10,000 objects in memory, just waiting for every single one of those promises to finally resolve. The system has no back pressure, it has no clue that it's literally drowning its own dependencies. Now, to really understand the damage here, we need to peek under the hood of Node.js itself and see how this flood actually breaks the internal mechanics of the event loop. Okay, so this failure shows up in three really distinct ways. First, you get these massive latency spikes. When thousands of promises all resolve at once, the event loop gets completely stuck processing them. It's called a microtask burst, and that delays everything else. Second, your memory just spikes through the roof. Promise.all has to hold on to everything until the single slowest operation finishes. So if just one request out of 10,000 hangs, all 10,000 results stay stuck in memory. And finally, your overall throughput collapses because the event loop is just starving, completely consumed with managing all these promises and trying to do garbage collection. So what this really comes down to is a trade-off. We reach for this unbounded parallelism because we want that high burst speed. But it comes at the cost of this huge systemic risk, which makes your system totally unpredictable. Now, the alternative, processing things one by one, yeah, it's slower for a single request, but it's stable and predictable, and that's what actually matters in production.
This brings us to the solution. We have to stop thinking about concurrency as some kind of magic wand for speed. We need to start thinking about it like a senior engineer would, as a finite resource that has to be budgeted.
This is the fundamental mindset shift right here. Concurrency isn't free. Every single concurrent operation consumes resources: memory, CPU cycles, database connections, you name it. You have a finite amount of these things, so you have to manage your concurrency intentionally.
So how do we actually do that? Well, let's walk through a practical playbook for engineering resilient systems that can handle the pressures of the real world. First, you have to budget your concurrency. Decide on a safe, fixed number of parallel operations, let's say 10 at a time, and don't ever let it be determined by user input. Second, build for back pressure. Use things like queues or worker pools so your system can gracefully slow down when its dependencies are struggling. Third, batch and stream your work. Process data in small, manageable chunks instead of trying to load everything into memory at once. And finally, respect upstream limits. You need to know the rate limits of the APIs you call and build those constraints directly into your code. And if you want to see if you have this problem, you've got to monitor more than just CPU. Watch for your heap memory growing with the request size. Keep an eye on your database connection usage. Track how often you're getting rate limited or timing out. And pay very close attention to your P99 tail latency. That'll tell you that while most of your requests are fast, the slowest ones are getting really slow under load. That's a classic symptom of system strain. Here's probably the simplest takeaway of all. Go look at your code and ask yourself this one question. What is the maximum number of concurrent operations this function can generate? If the answer is, well, it depends on the size of the input array, that is a major red flag. That's a ticking time bomb just waiting to go off. Ultimately, it just comes down to this. Using tools like Promise.all without any controls isn't making your system faster. It's just deferring failure, pushing it down the road to a moment when you're under peak load and you can least afford for things to break. It's like ripping the circuit breakers out of your house. Because in the world of large-scale systems, the services that actually survive and thrive are not necessarily the ones that are fastest in some perfect lab environment. They're the ones that are predictable, they're stable, and they are designed from day one to respect their own limits and the limits of all the systems around them. So I'm going to leave you with this one question to take back to your own work. Do you know what the real concurrency limit of your code is? And if you don't, are you absolutely sure you aren't just one large request away from a major outage?